impact transition. Let us reflect on these big 5 shifts. Number 1. DSN is transiting into a global operation beyond Nigeria under the DSN brand name. That is Data Scientist Network, with an existing learners network in almost 50 nations. DSN has become a global knowledge delivery network for the world. All its local and global extensions will now answer the DSN brand name. Number 2. DSN will run a dual business model as a social enterprise with DSN Foundation Nonprofit and DSN AI Innovations Limited, both in Nigeria and in the United Kingdom. This effort will position DSN for sustainability. Number 3. DSN is also changing its consulting model by becoming a distributed talent company. It will run a globally diverse network of expert consultants and partner companies who will collaboratively work with DSN full-time in-house staff to deliver world-class solutions under its new partnership program. Number 4. DSN is launching its learning network with more frequent online masterclasses, project walkthrough sessions, hands-on expert research sessions, and mentoring. These will be facilitated by some of the world's best experts. This expanded learning will also include dedicated programs for professionals, kids, researchers, and developers. Number 5. DSN AI Innovation will be unveiling Spot On, its geospatial AI precision analytics solution for retail and fintech, and ULearn, its AI-powered augmented learning platform that activates learning for every child. DSN is currently building more high-impact products in health, financial inclusion, agriculture, and others. It is a new season at Data Scientist Network, DSN, as DSN unveils its new logo to reflect its global positioning and expansion beyond Nigeria. The organization remains very committed to delivering high-impact AI solutions across the world while expanding its free training and research network across many countries. Welcome to the future with DSN. Powering 1 million AI talents and delivering transformational AI solutions for 2 billion people in emerging markets. The 5th DSN anniversary.
All right, good afternoon, or good evening rather, everyone, and thank you very much for joining us from wherever you might be joining us across the world. We're super excited to have you here today with us, and we hope you're looking forward to an amazing learning experience. To get us started, if I share my screen, I would ask to welcome everyone into the session. Why not please go ahead to help me drop your name and where you are joining us from today. It will be our pleasure to specially and specifically welcome you to today's session, because we are glad it's going to be an amazing one for you. So go ahead in the chat session, drop your name and where you're joining us from, and I'll be glad to welcome you personally. Right, I'll just go ahead to pull up my screen now in a moment. So who is going to get the ball rolling? Who is going to get the ball rolling? Thank you, Ime. I think you deserve a souvenir from us. You're the first person. Okay, thank you, Ime from Port Harcourt. Thank you very much for joining us. Okay. All right, so who else? Just a minute. Okay. So please keep it coming in, keep it coming in. I've seen a few more persons, right? So let me just go ahead to check the comment section. All right. Oh, Ayubami Yonda from Kaduna, thank you very much for joining us. And good evening. Moses, an MSc student from Unilag, awesome. Thank you very much, Moses, for joining us today. Tunde, thank you for joining us from Abeokuta. Godwin from Lagos, we're super excited to have you with us. Joy from Ilaro, Ogun State, thank you for joining us today. Okay. Dinka Michael, thank you. And Issa Bello from Abuja, Mayowa Dini from Calgary, thank you very much for joining us today. So I would ask the rest of us to please go ahead to drop your name and where you're joining us from. We are glad to have you in today's session. All right. So today's our second in the series of the master classes where we're unlocking the power of NLP and ASR for healthcare delivery. In the last session, we covered a whole lot on NLP, and I'm going to be doing a recap in the course of this introduction, right? And after that, we would see some of the things we covered. And if you were not part of that class, please do well. You can visit our YouTube channel, right? That class is on there. You can go ahead to watch and see some of the things that we cover. I will be doing a recap in this session. But in today's session, we're going to be looking at automatic speech recognition, ASR, and how it can be applied in healthcare delivery. My name is Uche, and I will be your anchor for today. I'm product lead at DSN, and with me, I have my colleagues on the session. We will be picking up your questions, and we'll be interacting with you in the comment section. Let's move very quickly to introduce who we are at DSN's Foundation. I'm aware that a couple of us, I expect that every one of us on this session already do know what DSN is all about, right? But for the benefit of those who might just be joining us for the very first time and who were not part of the class last week, right? DSN's Foundation, right, is the social nonprofit arm of DSN Data Scientist Network. At Data Scientist Network, our vision is to raise 1 million AI talents and build solutions and products that improves the quality of life and well-being of over 2 billion people living in the emerging markets. Over the last 6 years plus of our existence, we've built an ecosystem of 500,000 plus AI practitioners, experts, leaders, mentors, and learners who are consistently participating in projects, churning out research and white papers, and building AI-centric products. Our work has been recognized as some of the leading AI solutions and learning platforms and organizations across the world, like NeurIPS, Deep Learning Indaba, ICLR, AAAI, amongst others. We are privileged to have worked also with major companies and notable organizations that you are aware of, like Bill and Melinda Gates Foundation, MasterCard Foundation, TikTok, Meta, amongst others. Please feel free to visit our website to see a whole lot more of what we've done over the last few years, the awards and the products we built, and how we are investing and pursuing the development of AI talent across Africa through our community efforts. And if you're not part of our community, why not? Feel free to join us. It will be our pleasure to have you amongst us. Okay, so let's move very quickly to the recap of what we touched in the last session, which was the masterclass that we held last week. For those of us that are part of it, I'm aware, I believe you took notes of all of those things, but for the benefit of those of us who are not part of that class, I'll just run through this. In the last masterclass, we looked at NLP fundamentals. We touched on what is NLP and what exactly is NLP in healthcare, right? Specifically to healthcare. Then we deep dive into use cases of NLP in healthcare, such as patient history summarization, entity recognition and entity linking, how to use NLP to reduce manual paperwork, chatbots for question and answers, patient cohort selection and matching, clinical speech to text, and even machine learning translations that allows patients to speak when patients are speaking in a different language. We also did some basics, right? The bag of words, text processing, words to vector, auxiliary features, and looked at some NLP models like neural networks, RNN, GRU, LSTM, CNN deep neural networks, and several layers and contextual attention-based deep neural networks. Then did a deep dive on how to explore and classify medical text data. Again, the video of the session is on our YouTube channel. So again, I will request that you go ahead. If you want to recap on those things in detail, why not take some time, go to our YouTube channel and watch the video again. All right, now moving on to today's class. I mentioned that in today's maths class, as a continuation, we'll now be doing a deep dive into automatic speech recognition and how to apply it in healthcare. And we have an amazing speaker with us today who would be doing that for us. With us today is Abraham Owodunni. Abraham Owodunni is a machine learning researcher and a data scientist who has a broad range of industry experience, who has worked for over 2 years after switching careers from a health analyst. Now, his research has focused on natural language processing for low resource languages with Masakena NLP, and how to improve healthcare in Africa using artificial intelligence, which he did with Sisoke Biotech, where he was an active community organizer. He's also actively involved in several research work with open science communities like ML Collective, Open BioML, and Coherent for AI. He's currently investigating NLP areas and speech, multilingual models, and cross-lingual QA. Right now, Abraham is a researcher with Masakena, and today we are super glad to have Abraham with us in today's session, doing a deep dive into ASR and its application in healthcare. Hi, Abraham. Thank you so much for joining us today.
Hi, hello. Can you hear me?
Very well, very well.
Awesome.
It's a pleasure.
Thank you so much for having me. Thank you so much for having me.
Thank you so much. All right, you can go ahead, Abraham. Now the floor is yours.
Hi everyone. I hope you guys have been following, and I hope the last session you guys had a nice time from the last session. So I'm just quickly going to make a presentation before we go into like the hands-on aspect. My partner is supposed to do a little presentation. I don't know, Toby, if you're here, you could like signify. Otherwise, I could just go ahead and make the presentation.
Yeah, maybe I should just do the first 5 minutes and then.
Okay, so Toby has like some introductory stuff to share with us before we go into the hands-on stuff, which I will be taking. So please, you can make Toby a co-host while he like does.
Just share my screen.
Awesome.
Yeah, Toby, you can go ahead to share your screen. Thank you so much for joining us today, Toby.
No worries. Let's see. Okay. Can you guys see my screen?
Yes, we can see your screen. Yeah.
Okay, cool. All right, so I'll just do a quick intro to the topic and then say a few words about the competition, and I'll let Abraham take care of the rest. So we talked about NLP last week, and so this week we'll switch gears to focus on just ASR. So I'll provide some definition of what ASR is, how it works, and then pass it on to Abraham to do the walkthrough, basically. All right, so what is ASR? It's the acronym for automatic speech recognition, and basically it's all the computation that happens that allows your voice to be transcribed into text, basically. So if you think about how Siri or Alexa work, you say something, you say, Alexa, play, let's say a song by, let's say, Michael Jackson or Davido or something. The voice assistant or the agent has to listen. It takes your words as sound waves, and it has to figure out what is this person saying. You know that device Siri, it doesn't understand English. It's a computer, so it has to figure out a way to convert the voice signal to understand what you're saying and then give you a response. So if that interpretation does not work out well, it will give you wrong answers. And that's what you see in many systems today, when you say something to them and they do something entirely differently. So it means something is broken in that system. It doesn't understand your voice well enough. It may understand the voice of someone else, which is maybe someone that's white or European. It may understand that voice very well, but you may not understand your own voice because there's something missing in that, in the way it was developed. So basically, how does ASR work? I've tried to simplify it here into this. I see 5 steps. So the first thing is that you provide your voice. So you speak. When you speak, you are producing sound waves. You're producing your vocal cords, your lungs, they're producing energy. So you can just think about that as sound waves. There's no ABC in what you're saying. You're just producing sound waves. Think about it like a baby. When you talk to a baby, the baby doesn't understand what you're saying. They know you are producing some sounds. So just think about a neural network as a baby that was just born and doesn't understand any words or letters. And as you speak, they just hear sound waves. They're just hearing you saying blah, 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 blah. But they don't understand you. With time, they now learn how to interpret those sounds as words. So they learn daddy, they learn mommy, they learn food, they learn dress, they learn sleep. So they learn words to convert those sound waves they're hearing into words. They learn to translate it into words. So that's similar to what an ASR system does. And basically how it does it is that it takes your voice, this sound waves, and splits it into small slices, very, very tiny slices. Like you can see here, it breaks it into tiny slices, and then an algorithm is trained to translate that slice, just that single small slice, into text. So you can imagine that maybe one slice is translated into A or B or C or E or EF or GH, or it learns to convert a tiny slice. So it tries to simplify the work just to say, this very tiny slice of voice, I'm hearing what is the letter or what's the character that's been said. And so you go from the wave slices, your algorithm works on it and then produces letters and phonemes, and then all those letters are combined into words and sentences. So that's just at a very high level how ASR works. And every model you're going to work with in ASR is going to be doing a variation of this. It's going to take sound waves, chop it into slices, learn a mapping, basically a function that goes from a tiny slice to a letter, and then it's going to join all those letters into words and sequences. So basically, why are we doing this in healthcare? You know that in hospitals that are very busy, doctors can type, nurses can type, they know how to use a computer, know how to use a keyboard. However, given that they are seeing 30, 40 patients a day, the extra time it will take them to then type a document for each person, given that maybe the average typing speed is like far less than 50 words per minute, it will take them several extra hours to type documents every day. So we felt we can actually do something to reduce that documentation time, because if you don't solve that documentation time, many hospitals will not be able to go digital. Basically, they all want to go digital, but if it's taking them 10 extra hours to finish their work, nobody's going to embrace your system, and it's only going to be small hospitals that will be able to use your software. So that's one of the major applications that we are pursuing in healthcare at Intron. Last week, we talked about other applications like audio classification for speech defects, for search and all that. But today we're just going to focus on the application for transcription. And this is particularly important because there are many systems that convert voice to text in the world, but many of them are not particularly developed for African accents. And so what we did at Intron was that over the last year or two, we put together one of the largest collections of accented data. That's data from African speakers. The actual complete data set is about 1 million audio clips right now, but we've open sourced about 200 hours of that data, and that's what that's what the competition, the hackathon, and this tutorial is going to explore. So just one quick mention about the hackathon. The hackathon is launching tomorrow. If you go to Zindi right now, you should already see it. It should be public right now. You should be able to see it. And the cash price is there. So there's a bunch of data there for you to pull, and then you train models. I think the prices will go to the top. I think top 3 winners, basically. And you can see all the partners that we're working with, including DSN, where we're doing this masterclass today. So once this masterclass is over, I think everyone should just head over to Zindi to look at the competition and register and get ready to partner. But before we to participate, but before we do that, we'll definitely walk you through at least one example of how to train an ASR model, so that at least we give you some head start on the competition. I think that's it. I'll pass it off to Abraham, except if there are any questions from me before I go. Any questions before I go? Or should we just pass it off to Abraham?
Okay, maybe we could take questions also after this entire section.
Yep.
Awesome. Okay, thank you so much, Toby, for that. So basically, we are trying to use this opportunity to introduce you guys to the hackathon. When you have an audio data, how do you train a model to convert that audio clip that you have? Let's say you send a WhatsApp voice note, or someone you listen to music or something. When you have that audio clip, how do you convert that to like text file? A lot of people use that to, let's say you're in a Zoom meeting and you can't, or you're in a Zoom meeting and you can't watch the video, but you want the clip. You can pick the clip and convert it to text and go read if reading is faster for you. So there are so many use cases for this, and but basically we'll be focusing on the competition for today, and we hope that this is going to be like a kickstarting opportunity for you guys to head right into the competition and participate actively. So I'm going to share my screen now and walk you guys through the notebook we've prepared for automatic speech recognition. So yeah, so this is can you guys see my screen? Hello?
Yes, we can see your screen.
Okay, thank you so much for that. So like we said, this notebook is going to just introduce you to how to train a model for automatic speech recognition. And the aim is that it's going to give you an opportunity to start out so you can win the $5,000 that has been set for the competition. We're hoping that you can use this notebook, go through it. I have written comments, very descriptive comments that you can use to just read through, and it's going to help you understand what's happening, and you can tweak the model the way you want to achieve even better scores than we have in this notebook, and you can be the lucky winner of the competition. So in this notebook, I will just be walking you through how to train a whisper model. So a whisper model is like the current state of the art model for automatic speech recognition. So there are several other models, just like now when there's like, if you're familiar with other deep learning models, take for example, computer vision world, there's the ResNet, there's the VGG, there's the AlexNet, there's like a whole lot of them. So, but right now, Whisper is the current state of the art. And that's why I'm using that as an example to show you how to get better. To show you how to get better to get better at training automatic speech recognition models, and hopefully you can jump right in after going through this class. So basically, what we have for the entire data set, the audio data that will be presented, made a presentation about that we have, is currently hosted on Hugging Face, and it is approximately 120 gigabytes of data. And since we are using Colab just gives you approximately, let's say, 80 gig of CPU storage. So it might be a challenge for you to load the entire data set from Hugging Face. More about the data is going to be shared. If anybody wants to, you can follow along the notebook. I don't know if they've shared it to the chat. Let me check the chat if they've shared the notebook to the chat yet. Okay, so I can just copy it and paste now and share it for you guys since it's not been shared yet. So maybe you can follow along, and after the end of the class, I'll take questions as regards whichever parts you do not understand. So the first part here is how we fine-tune the model. So as I was saying that there's an issue with Colab. So we're going to be loading the data sets in a dynamic manner through this class, and hopefully you can use the dynamic manner of this class to go through the competition. So the Whisper model was actually trained on, I think, 680,000 hours of data, compared to the preceding models like WAFT-VEC, which was only trained on 6,000 hours of data. And that's what's made Whisper the current state of the art in the automatic speech recognition tasks in NLP. So right now it has a word error rate of 3 it has a word error rate of 3, and it also has a word error rate of 4.7 for different benchmarking data set that has been used. And that's made Whisper stand out because it was trained with label data compared to its preceding successors. So let me zoom in a bit so this is like better. So what does the Whisper model looks like? If you look through this is just a basic architecture of how the Whisper model looks like. First of all, you have the audio data. So if you look at this is supposed to look a bit familiar to you. If you're familiar with this app called Audacity, if you take an audio, there's this stuff that goes up and down, that looks like a graph or something. That's exactly what we take, but they call it wave. So that's what we take, and we convert it to a MEL spectrogram, and it becomes like an image. So the first thing you do is to represent the audio data in the form of an image, which is what's been done here. Then the next thing, you put it in a 1D convolutional layer, and then you just add like a GELUR activation function. Then you move into like the transformer network, where you have like a positional encoding on the side. Then you have like your encoder block, different encoder blocks, and it depends on how many you want to use. And then you pass in the context through to the decoder block, and where you also have like the text being passed into the decoder, and you also add your positional encoding inside of it. Then you have several decoder blocks, and hopefully like a linear layer. And after the linear layer, you have like a softmax layer, although it's not even shown there. Or you don't have a softmax, you don't have softmax. You have a CTC head. Yeah. So that's just the basic architecture of a Whisper model. The picture doesn't go so deep. If you want to read about like the Whisper model and everything, in this notebook, there's a blog post that's been attached. So you can like go there and read more about the Whisper model. So for you to use the Whisper model, like I said, is hosted on Hugging Face. There are so many other models that are hosted on Hugging Face. So you can use different models that suit your case. for the hackathon and for the competition. Whichever one works for you is best. But the aim of my class today is just to give you a very broad and robust option for you to pick from, so you can play with different things and try to come up with something unique for your submission for the competition. So the Whisper model comes in different sizes and different shapes. So there's the tiny, there's the base, there's the small, medium, and large. And it was trained on different languages. So there's the monolingual aspect of it, which was only trained on English, and there's the multilingual aspect of it. So multilingual meaning like it was trained with like more than one language. So the large size is currently not trained. There's no monolingual for the large size. So when you play with the competition, you can pick either of these models and try them and see which one works best for you. So the small model, which is what we'll be using for this competition, has it's approximately 1 gig in size, and it has 244 million parameters. You guys don't need to worry, although it's Colab can help you handle that, so it's not too big as 1 gig. So here the acronym for Whisper is Web Scale Supervised Pre-training for speech recognition. And like I said previously, this is currently the state of the art. If you're doing automatic speech recognition, you should be thinking of how you should go with Whisper and how to get the best of what's out there right now on Hugging Face. A more practical use case was when at Susunki Biotech, which is like a research community that I belong to, there were these doctors that came to us that they needed to make their things faster in South Africa they had too many patients and they wanted to make an automatic transcription. So as they are talking to the patients, they want the stuff to be recording by itself. So we gave them a solution of fine-tuning Whisper on African data set. So that's a more practical use case to this competition. In case you want to extend it beyond the competition, you could think of that. So
Hi,
hello,
Ibrahim.
I can hear you. I can hear you.
Yeah. I think if
I can hear you. Can you hear me?
Yeah, I can hear you now. If it's possible, can you zoom out your screen? I wouldn't know if everyone in the session can see. The letterings or the text on your screen are pretty much too small. I don't know if there's a place you can zoom out.
Okay, you mean zoom in actually?
Yes. It's very, very small, the text.
Now, how about now?
Better, a whole lot better. Thank you.
Is it okay, or I should continue increasing it if it's okay?
Yeah, guys, so it's okay for me. Hello, guys, on the session. If you just drop a yes, if it's okay, just drop a yes in the comment section. For me, it's good now. All right. So it's perfect.
Okay, it's
good.
Perfect.
So we can move on. Yeah.
Okay then. So so let's jump right into the code. So what happens here is, first of all, we have to set up our environment, and particularly GPUs. The model is big and the model is large, and you shouldn't be doing deep learning stuff without GPUs. So basically, this cell here just gives you the GPU information, and you can see the output. What I had while I was preparing the notebook was a Tesla T for GPU, and you might do yours and you might not get exactly the same thing. It does not matter as long as you have a GPU that gives you I think Colab gives you 12 gig of RAM for GPU. So that's what matters for you right now. And the next thing is to set up environment. After setting up GPUs, you set up environment, you just install some of the requirements, and these are Linux commands like app updates. Sometimes you use sudo, whichever one works for you. But you just run these and that's the output you get. And the next thing I do is to install the packages that will be used. So basically the packages that I'm installing here is a dataset package, installing the transformer library. I'm also installing the Libroso. Librosa is for managing audio. Like the part that I said, you convert your audio to picture. Librosa also helps with that. Then evaluating, when you train the model, how do you evaluate the model? And this is also part of model requirements as the Jira. and this just runs it, and this is the output you get. And I would advise, if you do not have so much space, especially if you don't have a page, if you do not have a page Google Drive, it might be very heavy for you to host this model and the data on your system, on your drive. So sometimes what people do is to push their model directly to Hugging Face Hub. Hugging Face Hub is big enough to accommodate almost all the models that you can push out. So maybe through the session, I'll just show you how you go through that. So what happens here is that right now the data is not open. So, but when the data is like publicly open, you won't be needing this particular block. But for me, I actually have to log into my Hugging Face account via my API. So if you register on Hugging Face and you log in, you can easily get you can easily get your tokens and your secret, your token, and you just put it in, and that's what you need to pass the stage. But after today, the data set is going to be made open, and you can just skip that phase and come here. So for you to load the data set that Toby described in the previous session, it's hosted on Hugging Face with this tag, Toby with the surname / AfriSpeech 2020, 200. Then once you have this tag, you use all to load all the data set. And since you can leave this as true, you can use this as false. It doesn't matter. What particularly matters is that you have access to the data set and if it's been open. And it's going to be open tomorrow, so you won't have to worry about that. One particular thing I want to mention here is that I'm loading this data now in the streaming mode. So what streaming mode means is that, because I told you earlier on that the data set is 120 gig, and that's a whole lot, the ideal way to do automatic speech recognition or any deep learning training is maybe for you to load, like to have the data set on your drive and be loading it while you're training. But right now I can't have the data set on my drive because it's too big. So what I'm doing with streaming mode here is to be loading it bit by bit. So let's say I'll load a couple of audio, train a part of the model, delete it, and download another one, train a part of the model. So that way I can optimize space. So ideally, that's going to make this tutorial, for those people that are already familiar with like using Hugging Face libraries, this tutorial might be a bit different because of this streaming mode loading. So, but I advise people that do not have so much storage to go with this streaming mode. If you have like enough storage, please feel free to download the data on your drive and use it. So if you just want to download one accent in the data set, so the data set has a couple of accents, I think almost 100 or so. If you want to download one accent, you're going to change this to the language name. And here you can see this is an example of how you load only for Yoruba. So the data set is in English, but the accent of the speaker is what this is referring to, which is Yoruba. It could be Igbo, it could be Tiv, it could be anything. Then this just tells, okay, which part of the data set you want to download. The data set is currently splitted into train, test, and validation. The test is not available for you guys, but you can use the test, the train, and the validation to train your model. And when it's time to submit, the test is going to be made available publicly for everybody. So to pick one sample from the data sets, you just pick in the data set that you've loaded. And like I said previously, the data set has train, validation, and that at the moment. So I'm just checking the validation. I'm iterating over it, and I'm just picking, like, using next to pick the first item. So when you do that, this comes up, and this is what the data set looks like. I hope you guys can see this. So the data set consists of like speaker ID, it consists of parts, it consists of audio. Then inside the audio, you have another part, which is similar to the previous part, because this other part is going to be discarded. Then there's the array, then the sample rating of the audio. Sample rating is like the rate at which the audio was recorded in. So this is going to be very handy for us when we continue. And the transcription. Transcript here is referring to like the text version of the record of the audio that you have. So we're going to explore that more in different samples. So I just want to play this audio that I have shown here in this particular cell. So this is what it looks like. So this is the text, and I hope you guys can hear when I play this. So you can just give me a feedback if you hear this, if you can hear this.
Infectious disease / cellulitis. Infectious disease / cellulitis.
So that, can you hear that? Did you guys? Okay, awesome. You heard that. Thank you so much. So that's what the data set looks like, and that's a sample. And if you want to now get more samples in the data set, you will go through the same method. You pick the data set, train inside of it, then you just take 2. This take, you put the number of samples you want to get, and it comes in the form of an iterative, like an iterator. So you have to use a list to convert it from an iterator to a list. So this gives you 2 samples because I took 2 samples from the data set. You see, it's the same thing, that speaker ID, the parts, the audio, the transcript, the age group of the person, the gender of the person, that gender of the speaker, the accent of the speaker, the domain of the speaker, the country, and the duration of the clip. So to see the second sample that I got, since I got 2 samples here, this is another one saying, in this 2 weeks interval, he denied having CP/chest and just chest discomfort or difficulty breathing, no cough, or hematitis. So when you play that, you see. Yeah.
This 2 week interval, he denied having CP/chest discomfort, difficulty breathing, no cough, or hematitis.
Oh, hematitis. Then that's it. So to move to the next step, what you can do, this place is totally optional, but I usually like to take out unnecessary columns. Since I have explained previously that what you need for automatic speech recognition, mainly, sorry about that, is the audio and the transcript. These are just extra things you need to know about the speaker. So for me, I just dropped them here by using the remove column method on the data sets that you've loaded. And when you do that, you still get your data as train and validate in an iterative manner. The next thing we want to do now is to prepare the feature extractor, tokenizer, and the data. Since we've loaded the data, the next thing to do is just prepare that. So the ASR pipeline, which is like the automatic speech recognition pipeline, follows a format. What you have to do, it takes a feature extractor, it processes like the raw audio inputs, like the image I showed you before. That's part of the feature extractor that's like converts the audio to picture. Then there is the model, which performs like the sequence to sequence mapping. Give me a minute, let me go back. So what I mean by sequence to sequence there is like, okay, you have a decoder, you have an encoder, and you have a decoder. It's not just like a single decoder. So that makes like a sequence to sequence mapping, and you just move the inputs from the encoder down into this encoder. Sorry, from the decoder down into the encoder, from the encoder down into the decoder, and that makes like a full end-to-end model. So back to where we were, and then you have a tokenizer. So the tokenizer deals with the text. What it does is generally converts the text to number. That is like what you can imagine that it does. But part of what it also does is to pad the text. And padding the text requires, like, let's say, if you're training a deep learning model, you want, when you convert everything to number, you want all the numbers to have the same dimension. Dimension in the sense that you might have sentences that are, okay, I am a boy, and the other sentence is saying, I am going to go to the market next tomorrow. That is very long, and this inconsistency doesn't work for deep learning models. So padding, what padding means is that you just add dummy numbers to make the sequence length. So you could add, let's say, the one that says I'm a boy, you need like a couple of other string, you need a couple of other numbers to add to it to make it equal to the dimension of the second sentence. So that's just what padding means. So the ASR pipeline takes in the feature extractor, the model, and the tokenizer. So we will jump quickly into loading the feature extractor. So this is, you should be familiar with this image when you take your recorder on your phone, you see something like this that looks like EGR or sorry ECG, or like it basically looks like a wave. And what happens here is the transformation. This has been transformed into this, and this image is now what's going to be passed into the model. So what the feature extractor also does, part of it is to pad the audio. So the audio is the model's taking audios with fixed length. So what would happen is if the audio is not up to 30 seconds, it can pad it. And if it's more than 30 seconds, it will truncate it. That means it's going to cut it to 30 seconds and make it a new sample. That depends on what you do, what you say. So first of all, there's the padding and truncation. Then what happens next is the log mail transformation. So, and that's all you need to know about that. And this is the feature extractor. So luckily for us, the Hugging Face Transformer library that we imported previously has the feature extractor for the Whisper model we're using. So I said earlier on that I will be using the Whisper Small for this practical. So if you want to load the Whisper Small, you can just go with OpenAI/Whisper Small, and that gives you the Whisper Small. So what I'm doing in this line is to load the feature extractor that I've explained what it does. Then after the feature extractor, what you do is to load the tokenizer. I've also explained what it does. So considering that the Hugging Face library, the Whisper model was trained for multiple tasks and multiple languages, and my data set is only for English and I'm doing transcription, that's why I'm specifying language here as English, tax as transcription. Tax could be any other thing other than transcription. There's also translation also. So that could be that you just need to read more if you want to like explore beyond the offers of this class. And what we do next is to combine these feature extractor and the tokenizer into one process so that like it becomes like a pipeline where it extracts the feature and it also tokenizes it straight up. So that's what you do in the next step. And that becomes a processor. And there's also the endpoints from the Hugging Face transformer libraries. That's a processor. So what I'm just doing is to load. So these stuffs that I'm loading are saved, let's say, data set and JSON files and pre-trained tokenizers and pre-trained vocabularies from Hugging Face. If you want to use a model on Hugging Face, most of the times they come with these packages and these accessories already on the Hugging Face model repo you want to pick it from. So I'm just picking the preprocessor and I'm loading it directly. And that has all these three lines of these three cells has taken care of you getting the extractor, the processor, and the tokenizer. The next thing, like I said previously, is to load and prepare the data set. So if you look at the data set now, this is like one sample, the one we looked at before. I told you that the sample rating is 44,100, which was what I emphasized on before. The Hugging Face, the ASR model that we're using today, it has a sample rating of 16,000 hertz, which is now not compatible. What we have to do right now is to transform this entire audio data set that we have from 44,100 to 16,000, which is called casting. So to do that, it's very easy. You just use the audio method from the dataset library and apply the cast method from the dataset that you have. And when you do this, what happens here is that you set the sample rating to 16,000 and it automatically changes it for you. So if you see here, where's it? This is 44,100, but right now the sample rating has changed to 16,000 You can also observe something very significant here. This array, which is like a representation of the audio that you'll be working with, has also changed. The first one is 0.00076,005. If you go back here, it is different here. This is 0.0007019. So that's just telling you, okay, this is what really happens beneath the hood. It changes the array to a different sample rating. It is the same data. It sounds exactly the same, but sample rating is just different. And the next thing we want to do is to now extract the features from the audio. We have the audio and we already have the array. We want to now extract it and also tokenize the text, which is what this method is doing. This function is doing here. It just applies the extraction and the tokenization in batches. And after you've defined the method, you apply the map. After you define the function, you apply the map method on your data sets and bringing in the function, and it automatically does that for you. And with this, you are done with preparing your data sets for automatic speech recognition, which is very straightforward. Quickly, we will move into training the model and evaluating the results. So what happens when you want to train the model is that you need an evaluation metrics. Evaluation metrics we'll be using here is word error rate. So if you want to read more about that, like you can just take the links here. So particularly word error rate is just saying, okay, there's the real label and there's the fake label. At what rate is the model getting the right words correctly in the transcription? That's like a very simple definition. So, but what we'll be using to train this model is the Hugging Face trainer. Hugging Face trainer can train different models for you. You can train computer vision models, you can train normal NLP BAT models, and you can also train audio models for you. So we'll be using that. The evaluation metrics is what error rate, and we'll be loading the model like we've loaded the tokenizers and everything from a checkpoint which is hosted on Hugging Face. And I will just walk you through that. So, but before that, you need to define a data collator. A data collator is what actually applies the padding. You know, I said tokenizer, it converts the word into numbers and integers. What the data collator does is to help you, okay, yeah, sentence 1 is 10 words. Sentence 2 is 200 words. We need to make them the same length. That's how data collector comes in. Data collector also helps you to apply badging, but we won't be using badging since we are streaming these data sets right now. So like I said previously, the model takes 30 seconds, and whatever is 30 seconds is cut down, and whatever is not 30 seconds is moved up to 30 seconds by adding extra tokens to it. It also returns data sets for you in a PT format, and PT here means PyTorch, and it adds some special tokens to the data. So you want to tell the model, okay, this is where you start. This is where when you want to predict, this is your start sentence token, and let the model know when the model predicts an end sentence token. It says you let the model know, okay, this is the end. So those are special tokens. You can also add special tokens. The Whisper model has special tokens for if you want to let the model know, oh yeah, I want to do transcription, I don't want to do translation. There's a special token to indicate that. I want you to know this is where the sentence started, this is where the sentence stopped. Those are also special tokens. That's what that also helps you do. So here, when you define the data collator class, and this underscore call, what it does is that when you call the data collator, it automatically calls the function instead of you to define an independent function inside of the class. So that's very straightforward. This extracts the feature from the data sets that it's been passed in, and this makes it in form of a badge. And like I said, it returns a PT format, and this now handles the label. It takes the label and after extracting it, it also returns it as a PT format. And what it also does now is to mask it and add a -100, which is like a suppressed token that represents also a special token. And after that, it returns the label in a Whisper convenience format. So here it's saying self.processor.tokenizer. Beginning of sentence token. So this is adding a beginning of sentence token to them, and beginning of sentence token added to the text in particular, in case anybody's confused as regards that. And it returns the badge. So what just happened is, preparing the audio, we've also prepared the adapting the audio to fit into the whisper model, and we're also adapting the labels to fit into the whisper model. What happens here is not very rigid. It is model specific. So you also have to investigate in the about the model. But the pipeline of, oh yeah, you adding tokens, special tokens, everything here is the same format you follow for Whisper, for ASR. So the next thing here is for you to, now the data collector that we defined, we just call the class and add we add the processor that we also defined previously inside of it. And the next thing you go to do is to load the evaluation metrics. And the evaluate method, as the evaluate library already gives us an easy option to pick up word error rates. So this could be any other evaluation metrics. It could be F1 score, although for automatic speech recognition, what you're using is not F1 score. What you're using is word error rate. But let's say you're doing a sequence classification task right now. You could be using, let's say, an F1 score. You could be using precision classification, accuracy, and the likes. So, but we are just loading the metrics here. And now that you've loaded that metrics, you want to now define a function that picks, okay, now the model has made a prediction. What that function does is to pick, okay, it picks the transcriptions from the audio, and it also picks the target label, that's the correct transcription, and it compares that for you. And that's what's happening here. You can see here there's spreads ID and there's label ID. It's just like, how do you put, yeah, when you want to do Y test and X test in normal traditional machine learning. Yeah, is it Y test? Y pred, sorry, Y pred and Y train. Yeah, something like that. That's how it works. So after you pick that in from the model, this removes the token that we added previously. And it represents the token that we added previously. And this now converts. I told you that it's going to, what happens is that the strings and the numbers, when they are tokenized, they are converted to the strings. When they are tokenized, they're converted to number. What's happening here is like it is reversing the process and it's converting it back to strings and back to words. And you now compute the accuracy by comparing the predicted string and the label string, and you get the word error rates, and then you return it. That's the entire thing that this compute metric does. And we move forward to when we have to load a pre-trained checkpoint. A pre-trained checkpoint is, in summary, a model that has been pre-trained somewhere. Maybe you have it on your drive, maybe you have it on Hugging Face Hub. You just download it and you load it directly. So when you have that, this is the checkpoint that I'm loading. So if you observe something, all this, if you observe where I've been loading from, it's always OpenAI /Whisper dash small. That's because when a model is pre-trained, it is sent together in a, let's say, directory, in a repo, in a folder with the tokenizer, everything that's affiliated with it. So all I'm doing is just loading from the same folder, the same model, give me the model, give me the tokenizer, give me the processor, and give me everything that's related to it. And that's what's happening here. And here, what's happening is that I'm suppressing some of the tokens that are not good, that are not relevant for our, I'm specifying that, hey, the tokens that are not useful for this class, since we're doing English specific, should be none, because I don't have any particular character in my data set, in the data set that sounds very foreign or that looks very foreign, that the model might not entirely understand. And here I'm setting model configuration to use catch equal to false. So use catch means like it shouldn't save some part of the data while training to make it faster. You could also play with that if it comes to, if you feel like. And the next thing we have to do is to set up the trainer. I said trainer. So, but the trainer takes an argument. You can read more about this argument, but I'll just go through the basic preliminaries that I said. So for me, I want the model, when it's training, it should be saving the stuff. It will be saving the models to a folder called DSN free speech. the number of devices, it should use, the batch size for training is 8, the gradient accumulation step is 1, and the learning rate is this, the warm-up step, the max step, like that maximum number of steps. Gradient checkpoint is also true, the flip. So these are like basic stuff that I set for my model configuration. It's just like you, when you want to do, let's say you're using TensorFlow, because I know a number of people are quite familiar with TensorFlow. It's just for when you do your batch size, your split, your number of epochs, and it's very direct. So that's almost the same thing here, although this is more broad and more expanded. One interesting thing that I did here, since I did not push the model to the Hugging Face hub, I didn't use this equal to true. If you want to push your model to Hugging Face hub after you're done training, you can set this to true. I just commented it out. You can set it to true, and what that gives you the opportunity to, let's say you're on another machine another day. It's just like a GitHub repo. Exactly, Hugging Face hub is like a GitHub repo. You can easily go pick your code another day on another system from a GitHub repo. So that's what happened here. You can easily pick your model from the Hugging Face hub somewhere else another day, and you can share it with someone else. But for this to happen, this login, let me go back a bit. So I'm sorry. This part that I logged in, yes, it's this has to be like, you have to set that, like you have to log in, get your token and everything for that to happen. Or you could also use like your token manually, but it's really not advisable to like just paste your token in a notebook in case you share it with someone else. The person might see your token and do something not really nice with your tokens. So it's just good that you log in normally. Yeah, so this is most likely repeating what's happening there, setting cache to be use cache to be false. So what now happens here is, now since I have defined the arguments that I want to set while training, this now defines the trainer. The trainer is now what? Okay, I told you that the model is a encoder decoder model that has 2 parts, which is what makes it a sequence to sequence model. So what's happening is it's also training the encoder part for you, and it's also training the decoder, and it's like matching everything. It's taking care of everything for you. And here you just here you set the training argument, which is this argument that I've set here. You just put it there. Then you say the model. The model, we find the model that I loaded previously. The training data set is data you prepared. So I'm just selecting the training from this data set. Here I'm only taking 10 samples because it's a practical, like it's just a demo. You should ideally take the whole data set. So which means like you can take this out, and that works. And you can also take this out. And after that, everything is fine. What we have to do is save our processor, so that when we want to use it another time, we can easily load our processor and just like use it to process your text before you make prediction. And we quickly move into the next thing, which is trading. So like I said previously, this notebook and this particular class has been designed in such a way to understand that people that will be participating in this competition most likely do come from a low resource background. And low resource background also involves you not having money to pay for Colab Pro. And therefore you have to use the basic offer from Google Colab, which is the 12 gig GPU. So another thing that the Colab Pro doesn't, the Colab Pro gives you an edge over the free Colab is you having to train for a longer period of time, and like you don't have, your stuff doesn't disconnect while you're training. So there's this trick that we use, since you might be training for like 10 hours, 20 hours, and it depends. You'll be training for a very long period of time. Colab, if you've used Google Colab enough, if you do not like engage with the platform a lot, like while for a very long period of time, there's going to be this pop-up that comes up and say, are you there? And we ask some questions. If you do not respond, or if you do not click the captcha like checkbox, it automatically disconnects your runtime. So, and you wouldn't want something that when you have trained for 6 hours, let's say you sit down with the model for 6 hours, and let's say you just go do something for like 40 minutes and come back, and your whole 6 hours is gone because stuff disconnected you. So what you should do here, this stuff is very direct. Sorry, this is not what's supposed to happen. You right click the mouse, you inspect, and you go to control console tab and you insert this code. So what you need to do is to just come and you just come copy the code. So this stuff is also this step is also specific for browsers. Right now I'm using the Mozilla Firefox. It could be a bit different for Chrome and everything. So here it just says you right click inspect. So when you inspect, you go to console. So this is my console, and you just come here and you paste it, and that's all. And you paste the code. This is going to help you overcome that challenge of you having to always be clicking I am there, even though the stuff knows that you're training. And it helps you not go through the whole memory timeout stuff. So what's now happening here is that I am clearing the GPU just to make sure that I didn't mistakenly use part of the GPU, because for my training, I want to make sure I use every single available space on my GPU for my training. So I'm clearing it completely to make sure I have everything open. And the next thing to do is just for you to run trainer.train. When you run trainer.train, the training begins. And when training begins, you will see something like training running, number of examples is 24, and number of epochs. I mean, this is not exactly true, and so don't mind that. Then the batch size on device is 8. Then total batch size it's 8 also. Gradient accumulation step is 1. This is like for the practical. And it just shows you what you defined in the training arguments previously here. It just print out some of them. And when you see this is like my training. I only trained for 3 steps. And you can see that I have training loss of 4.36. 4.36 word error. Sorry, the loss is 4.36. The validation loss is 3.64. And my word error rate is 107.5, which is a bit high, and it's not so cool. That's because I only took 10 samples for my training. So you shouldn't take 10 samples, you should take quite a lot. But you're going to be surprised that even with these 10 samples that I took, the model still performs pretty well. Why? When we get here, you'll see. So after it's done training, you're going to see the output that says training completed. Do not forget to share your model on the Hugging Face hub. When you share that, everybody wins, and it now also prints their final outputs for you. And what I'm now doing here is to save the model that I've trained to that output directory. You can see that it's saving my checkpoints to DSN_average page, and it's saving my config and all those things that are necessary for me to pick this model, let's say tomorrow or next month, and continue from where I stop. That's the beautiful part about training. When you train, you can train now, and let's assume you're training and your GPU, you run out of GPU. You can just save the model, and when your GPU usage opportunity comes back, you just load the model from where you stopped and continue training. That's just how beautiful it works. So, but you need to save all these for you to be able to continue training. And also the processor that we had previously, I'm also saving it also to a different path now. And the next thing for me to do is, if you want to push your model to a hub, this is like the way you go about it. You just set the dataset tag. You can easily copy what we use. This is the dataset tag. The title of dataset is average page. The configuration is English. The split is test. The split is for your own. The split is going to be for train, but for the competition, the split is test, and the language is also English. The model name that you used, you can give your model a name on the hub. So me, I'm giving it Whisper Small ENG OWOS, which is like the short name for myself. And fine-tuned from, I'm now saying, hey, I fine-tuned from whisper small. And the task that I did was automatic speech recognition. And the tag that I'm giving it is like HS ASR leaderboard. So it helps you also compare your model with other models on the Hugging Face Hub. And now let's move on to prediction. You've trained your model, you've saved it, you've also prepared your data and everything works fine. You now want to predict. The easiest way to predict is I'm going to take sample from data set. So of course, this is data sets you're working with before. So I'm taking the data set sample, I'm taking a validation from it, like one validation. And I am also taking the audio part of the data set. You know, I showed you previously that like the data has so many fields. So I'm taking the audio part of the data, and now I'm sending it to my to the GPU. Since the model is currently on the GPU, I'm sending it to the GPU, which is like if CUDA is available, then send it. If the CUDA is available, then like let's use CUDA. So now I'm also picking the feature inputs. So remember this processor that we defined previously. I'm just picking this sample that I have, the sample rating, and I'm telling it, hey, return for me a Python version of this array, and also send it to device, which is GPU. And when you do that, the next thing you need to do is you pass your model, so model.generate, and you put your input picture, which is what we just defined, and that's everything. Use generate here. Since we are doing more like a generative task, it generates the text for you. And when you generate the model, you know, the model works totally in numbers. So when you generate it, you're expecting to get numbers, of course. You have to now still go through the process of converting those numbers to strings, to a sentence that makes sense, to a meaningful sentence. And that's what happens here. You now say the processor that we used before is a batch decode, and you put in these prediction IDs, and you also say skip special tokens equal to true. Skip special token is those special tokens that I told you that were added before when you were preparing the data set. So okay, no, this is saying skip special token equal to false. I just want to show you what comes out of the model with the special token. So this is how it's been predicted when it comes. So you can see here, it says this is a special token, start of transcription, transcribe, no time stamp, then it now gives you the prediction. So it says we should be asking ourselves whether we want to take a heavy-handed approach and the end to stop. Then it also predicts an end of text. Now, if you set that skip special token equal to true, it removes the special token and you get the entire sentence without any stress. So you want to do when you're like making a submission, you want to skip your special token. You want to make it skip special token equal to true. And let's imagine I'm loading the model another day from my PC. I saved it on my PC. What I just showed you previously is like I train and I'm evaluating and I'm predicting. The easy thing for you to do is to just load the model from the DSN after speech folder that we created previously. You just put it like inside load from pre-train. You also load your processor, and now I am sending the model to device. Why? Because I just loaded it. Previously, when I trained on device, so the model was still on the device. Right now, since I'm just loading the model for the first time, like afresh from my local PC, I have to push it to device. And when you push it to device, you can now see what's happening under the hood. It's printing the model config. You can see that chunk length is 30 seconds and some other things that are there. These are a lot of the special tokens that are added for different languages. You add different special tokens for different languages. You can explore it further if you are so curious about like the number of languages it has. They are there, the configuration for the model, and also the configuration for the model, and also the special tokens the model has. So quickly, I will move on to the next part. So because it's like that stuff is a bit too long. Awesome. And the next thing you have to do, since I just loaded this model, I kind of use the model and generate. You can see that it gives the same thing, and it gives you the model with tokens. It gives you the predictions with the tokens, and when you skip special token, it also gives you the sentence. So this is how you walk through training a model from start to finish for automatic speech recognition. So if you want to like read more, you can go to this blog post that I attached here to read more and like expand what you want to do for the competition. And there are other models. You just need to go. If you want like to get more complex code, you can just go to that link and it takes you to a repo with like more complex code on Hugging Face for automatic speech recognition. So just to help you guys, if you want to participate in the competition, there are so many things you could do. You could first of all try zero shot prediction, where you don't even fine tune the model. Like we say, these are pre-trained models. So sometimes you could use them off the shelf. So you don't, if you don't like, oh, you just want to see what you get at the beginning, you can just send a prediction from a not fine-tuned model. You could try different sizes of the model. So I used small for this competition. You could try tiny, you could try large, you could try base and other ones. If you want to, you could try other models. It doesn't have to be Whisper. You could try WAF to Vec. The process is similar. You just need to pick it from this notebook and try a new model. So I think with that, this is everything you need to know as regards training a, let me close this, a Whisper model for automatic speech recognition. And you also can start collecting your data in case you want to expand your knowledge beyond the competition and start training your own model. Let's say you want to train something for Yoruba language, or maybe you want to train something for Hausa language or something. As long as you can get the data and you can get the text, I think you're good to go. So I will take questions now. Thank you so much.
Thank you very much, Abraham, for that enlightening session. Thank you very much. So guys, I mean, we've gone through a whole lot. Abraham has touched on a whole lot on the ASR and all he's been able to do here in training the model and even working it for you. So please, we would need, if you do have questions, this is the moment for you to go ahead to ask your questions or clarifications, right, over the course of the next 10 to 15 minutes. Abraham will be taking our questions. So please, I haven't seen any question here in the comment section. Unlike last week, guys, is it that we understand everything Abraham has been explaining, or we need time to digest and distill it? So please, if you do have questions, why not just go ahead to drop it in the comment section and I'll pick it up. Emailing answers, I still feel new. I mean, it's understandable, right? So you can just take some time to distill all of these new concepts, right? You will definitely get a grip of it over time. Okay, so while I'm waiting for the questions, I'm just going to pull up my screen. Abraham, can you please your screen so that I can pull up this my own screen? Thank you very much.
Okay, no problem. I should stop sharing, right?
Yes, yes, while we're waiting for the questions from our participant. Yeah. So guys, if we do not have questions, right, then I think it's only ideal and not necessary to go ahead to just show appreciation in the comment section, right, for that amazing walkthrough deep dive.
I think there are a couple of
done.
Okay, hi. I think there are a couple of questions
there. Okay, yeah. Let me see now. Okay, someone just asked one now. It's not related to the text, but you can just quickly comment on it. It says on Zindi, it says 4K USD and 5K here. So perhaps that's like a typo. Abraham, the hackathon.
Yeah, no, I think that it's 5K. It's 5K. Yeah. For the hackathon. Another person is asking, how do we?
Okay.
Yeah.
Yeah. Go ahead, Abraham.
Another person is asking, how can we get The data set. So the data set, there's a
The
data
data
set
set for
page
this
on
language
Hugging
recognition.
Face
Yeah.
for language recognition. It's not exactly language recognition. It's more of like text transcription that we are doing here. Sorry. So it's more of text transcription, not language recognition. So, but the data sets, every data set has a data set tag on Hugging Face. So like I showed you while I loaded the data sets, you just need to like go pick the data set tag. I'm sending the data set tag for you on in the chat. I am not sure if the data set is currently public, but they gave me access to the data set to work with. So if it's public, you should be able to see it. Let me see if the data set is public and I'll just share it with you. So, but I think when the competition starts, the data set is going to be public for sure.
All right. Thank you very much, Abraham, for that. So guys, any other question or any other clarification that we might need? Okay, Adeni just said, do you have any video recommendation to enable someone learn this from scratch? Abraham?
Okay, so video recommendation. I don't have any off the top of my head, but you can easily check YouTube for like ASR basics and you get ASR basics. So these are high level stuffs, and ideally for you to like understand what's going on under the hood, you're supposed to train your own model from scratch, but you can you most times we do not have the compute resources to train a 1,680,000 hours of data of speech data. So people just opt for using pre-trained models. So, but if you check YouTube for introduction to training or building automatic speech recognition models, you can see that. So one thing you should start with is to understand, if you understand what's the entire pipeline and how it works, how you have to have a data that is the text and also the audio, and you also have to have the audio in a particular sample rating, and you know that, okay, the data that I have, which is a text, I can't move it like that into my machine. I have to make it, first of all, a number, so which we now start by like, you now tokenize. Then I know that, okay, I can't have sentences that are of different lengths, so I have to pad. So I have padding. I explained padding before. It's like you're adding, like the clothes doesn't fit in well, right? So you're now adding extra clothes to the left and right to make it comfortable across boards. And you do the same thing for the audio. And since it's just like normal putting a data which is now in form of number directly into the audio, and you're good to go. So I know that's a bit high level, but you could check YouTube for more resources. If I have any after the class, I might share or something.
All right, thank you, Abraham. Adeniji, I hope that provides some clarification for you, right? So, Abraham, there's a question I think from the YouTube audience. Said, how long do you think it would take to train all these data sets that you made use of? How long do you think it would take to train them?
So the entire data set for the competition is 120 gig. Another thing you could do, like I suggested previously, that there are so many things you could do in the competition to add flavor to your submission. One thing you could do is to not take the entire data set for training. You could take half and hope that your model performs really well. But I didn't train on the entire data set, and the model performs really well because it's a pre-trained model. It has been pre-trained on very good quality of text and audio. So I did not train it from start to finish, but honestly, it's going to take a while for you to finish training it. And that's why you have the Google Colab stuff there. And that's why you also have, I try to put in that stuff that helps you keep your Colab session activated for a very long period of time, because I know it will take a while for you to get through the training. So off the top of my head, I have no idea.
Right. So Anthony, you can just, I believe the person who asked that question, of course, the answer that he needs. The questions are coming in now, Abraham. So there's another question here from Ayomide. He said, is this also the same as natural language processing NLP? Looking at the pre-processing method, and it says it's almost the same. So she just needs that clarification.
Yeah, so okay. So this is NLP, and this is like a subsection of NLP. Natural language processing, if you think of it from a very high level, it's like understanding language. I mean, some people come into natural language processing from the biological background where you're trying to process DNA sequences and you're trying to like build a model to understand the DNA sequence. What you're doing is to build a model to understand genetics, as long as it is a language and you're trying to build a model to understand the body of the language. So here we're working with English, we're working with, it could be Yoruba, it could be anything. So this is natural language processing and a subsection of natural language processing, even given the fact that a lot of the things we do is like, it cuts across broad in so many natural language processing tasks. So yes, it is natural language processing.
All right, thank you very much, Abraham. So the next one, you may just wanted to know if we're getting the links to this. So Abraham, we believe you, all of this, the link to the work you just done, right? The Jupyter notebook that I think you used, right? You're going to be sharing with us, so we could share with the students. Is that fine?
Yeah, I shared it previously in the chat. Like I shared it previously in the chat before I started, so people could follow up. But I'm sending it again.
Exactly. So we could send it to the participants' email directly.
Yeah.
All right. Thank you very much. Email. Okay. So on that question, so I think of course appreciates the session and this connectivity issue on Collab. Okay. All right. Just an appreciation. Thank you, Adenka, for that thoughts. Ayomide has one. He said, also, can I use ASR for building an AI voice assistant? That's the question. I think that's the last one we'll just take for today because of our time.
Okay.
Abraham, can she use
so
ASR to build an AI voice?
Yeah. Yes, you can. So this is what, if you break down a voice assistant, what happens is that you talk to the model, you talk to the Alexa, or you talk to the Google Home, it records your audio and tries to understand what you're saying. If you can break that down to, okay, after getting the audio, it transcribes it to text, and it depends on what you now want to do after. Maybe you want to do information retrieval to get like what's more closer and return it, like the way it works for ChatGPT. But you can use that to build an AI assistant by just doing the transcription and using the transcription to execute some tasks behind the hood of your voice assistant stuff. So I think that's it.
Okay, guys, so because of our time, right, we won't be able to take any more questions. I believe what I would request for Abraham, right, because I believe that a whole lot more persons here who would like a lot of clarifications and still have questions, even as they interact with the notebook, right? They might see the clarifications. Would it be fine? You could just drop your links in ID so that they can follow you on LinkedIn and also kind of like receive some mentorship or clarifications from you. Would it be fine, Abraham, if you want to help us do that? So that this for other questions, we can follow you. All right.
I will share.
So thank you very much. Guys, Abraham, yeah, thank you. We'll drop in his ID in the comment section so you can follow him up on LinkedIn and then you can ask more questions. Remember the hackathon, like Toby mentioned earlier, if you didn't join us early enough, right? The hackathon commences tomorrow. It's already on Zindi, right? And clarifications that are needed, reach out to, you can reach out to us at DSN, our community leads, right? We'll be willing to provide you with all of the clarifications you need. And also, why not? If you need to reach out to Abraham on LinkedIn or Toby, he dropped his LinkedIn profile ID last week, so you can go ahead to reach out to him for clarifications. It's an opportunity to learn, to practice, and also explore the opportunity of winning $5,000. All right, thank you very much, guys, for being a part of today's session. We are super excited and super glad that you stayed all the way to the very end. And I believe that you found the session really insightful. Thank you, Ayomide, for that comment. So the next thing, like I've mentioned, is the hackathon, and I wish every one of us success as we participate in the hackathon. Why not just give it a try and see how much you can go, right, based on what you currently have learned, both from the first masterclass and this one. I trust that you have an amazing evening, and we look forward to your submissions in the hackathon in the coming weeks. Thank you, everyone, and do have a very great evening. Bye for now.